So when we talk about chemistry, so the course code for this subject is 0620 for IGCSE, right? Again, just like physics, it is going to be paper 2, 4 and 6 with the same distribution of marks and the same assessment skills to be used. As I said, this is going to be much more faster. It's the same as just as physics, same for biology as well, right? So I'm not going to go into much of the detail because I've shared the document with you people. You can easily go through this at your ease. Just a moment. I need to add. Let me get back. I think Maria is also joining. Yes. Okay. As I was saying, that it's the same for all three subjects, bio, physics, chemistry. So I'm just gonna go through this quickly so that we can move on to our first topic for chemistry today, and we cover our first topic because physics I'll be able to cover more quickly, but chemistry is going to take more time because it's got more content to cover than physics, because physics is mostly conceptual, right? So over here I'm just going to put these multipliers, right? Keep in mind that I was talking about this in physics, that these are multipliers for this. What these multipliers hold for, this is what it means, right? For paper 2 you do have 40 marks paper, but it holds 60 points for the final grade. Similarly, paper 4 holds 80 marks but has a multiplier of 1.25 and holds about 100 points for the final. And for paper 6 it holds a multiplier of 1, so 40 marks mean 40 points. That means if you lose 3 marks in paper 6, that means you have lost only 3 points in total, right? But if you miss 3 MCQs, now look at this weightage over there, that MCQs are more important than all the other 2 papers, right? If you lose 3 MCQs, then you will probably be losing 7 points in the long run, right? So keep in mind, no, 6 points, right? So 6 points you will lose just because you got 3 MCQs wrong, right? So you will lose more grade points for the final grade in MCQs compared to paper 6, and you will lose consequently a little less marks than the MCQs in paper 4, but still higher than paper 6. So paper 6 is the least you can say important in terms of your final grade. MCQs turn out to be the most important. So my target for the kids who are working with me is always no, they have the least amount of time, but it's not about the time, it's about how many you will get wrong, right? So the minimum target for MCQs is going to be 35 for you people. So keep in mind, any less than 35 and you are drastically risking your grade, right? 32 is the minimum mark, but for you people, I know all 3 of you are smart enough, so I expect that 35 is the minimum target. I've had students who have scored 38 and 37. Over here we do have Ira, whose brother has already scored 37 marks for me, and I'm very happy with his score. He's a brilliant candidate, just like 3 of you. I've chosen only the best. You do see that I'm not incorporating anyone who's below a certain intellectual level. You guys know me, I'm racist in that regard. I only work with the intellectuals, right? So that's the very reason I've only shared this class for very few kids who I knew would be interested and would work for it, right? Not for everyone, right? Okay, again the same percentages, so I'm not gonna go through this. Okay, now this is where it's going to be different compared to the physics orientation, because I will now start discussing the topics rather than just the syllabus document, right? Now, what is chemistry? I define it that it's a subject that studies the composition of a matter. So what is composition? What is it made of, right? So spoons are made of metals, right? We know it's made of steel, stainless steel we say, right? We also see gold spoons, right? Then chair is made out of wood. So we're discussing composition. What is it made of, right? And then we have processor. Yes, there are many ways. I'm just giving few examples, right? Just trying to build it up. That processor is made of silicon. Wires are made of copper. Just a minute. I think we've got someone join. Oh, Maria got lost again. All right. Okay. Since this is just going to be a 2-day trouble for you people, once I add you in the group and add you in the team, then you will be able to join in without me accepting it, right? So we were just discussing that things are made of, like wires are made of copper, and structure cables, the bridge cables are made out of steel, which is 98% carbon, 2%, 98% iron, 2% carbon. Then we have table salt, which is made of sodium and chlorine. We call it sodium chloride, or NaCl. So this is what it means to study chemistry, that you're trying to understand the composition, what things are made of, right? What elements they are made of, what molecules they are made of, what kind of structure they are made of, compared to physics, where we're discussing the other properties of matter, where we understand how the energy is interacting with matter. We will study a bit of energy interaction with matter, but at a compositional level, right? So similar way, I have divided the chemistry into several blocks. The first one is physical chemistry, that discusses the behavior of materials, right? How physically different chemicals, different elements behave. For example, metals can be bent, ceramics or glass cannot be bent, it breaks, right? Wood is flexible, it's light, right? Metals are heavy, but they're flexible, but they're very heavy, right? And then you also have plastics, which are deformable, but they're not heat resistant. Yes. Yeah, they're all shiny. Yes, diamond is very hard. Yes. So there are many ways. As I said, we'll explore all these, right, in detail. Then we have analytical chemistry. Now this is my specialty of the subject, analysis, right? When we say analysis, we're trying to understand what is the composition of a material, what is it made of, right? What are the elements behind it, how they're bonded together, how they're made, how we can convert one form of elements or one combination of elements into another. Maybe you can say chemical reactions of sort, right? So we'll be studying those in analytical chemistry. Then we have inorganic chemistry, in which we study the properties of acid, base and salts, and that means inorganic compounds only. Alright, I'll discuss what an inorganic compound is and what an organic, on the contrary, is. These are two opposite. Both of these combined complete the whole cycle of chemistry, right? Both inorganic chemistry and organic chemistry, when they join together, that makes the whole system of chemistry, which we study as analytics or physical behavior or other, right? So in hydrocarbon, we deal with compounds that are made of hydrogen and carbon only. Then we have organic compounds that may be having carbon and hydrogen, but others like like oxygen, like nitrogen, like amino acids, like alcohol having oxygen in it. Then we have polymers, how different hydrocarbons and other functional groups like fluorine, chlorine can join together to improve their properties, right? So we will discuss all of that in organic compounds. Also consider that biochemistry is also branch or sub branch of organic chemistry, because we are discussing organic compounds which are biological in nature or have biological applications. None of the inorganic compounds are biological in nature. They're only as working as salts or ions in biological systems, right? We take salts so that our ion system in the body, or ion ratio in the blood, remains constant, right? Or stabilizes, so that the homeostasis of the body stays stabilized, right? So again, inorganic chemistry is just a resource, an inorganic resource for the biological systems. It does not mean that any of the biological compounds will ever be studied in organic chemistry. We only study those in organic chemistry entirely, nothing to do with inorganic, right? Okay, then we will go into the domain of industrial chemistry, in which we will study chemical processes that are used for production of chemicals, like acids, like gases, how we obtain certain amount of gases, and then how we make salts, and many others, like metal extract. There are chemical processes we use, right? Then we have environmental chemistry, which studies the impact of chemicals on environment. And finally, we will study electrochemistry, in which we'll see the electrical behavior of materials, right? How different materials have joined together create electrical discharges, or how we can give electrical discharges to some chemicals and change their compositions, right? We have studied the term electroplating so far, right? In which we use electrical energy to plate one metal onto another. For example, we have gold plated blocks of bronze, like gold medals that people give around. They're not made of gold, because gold is very expensive. So we just put a very thin coating of gold using electrical process we call electroplating, which is electrochemistry. We give electrical current, we give a specific salt solution, and then we dip two metals together and we coat one metal onto the other. So we do compositional changes using this. Then we also have batteries that has compositional changes, creating electrical discharge for you, or electrical power for you, right? How chemical reactions create electrical power, or how electrical power can do chemical reactions for you. So this is what electrochemistry is all about, right? Now, topical distribution, how your book is going to be distributed in terms of these branches, since these blocks are not there compared to physics, in which blocks were used to be there in the books, but now I don't know why they have removed this block distribution, which was very easy to understand, right? Now when we talk about physical distribution, so when we talk about physical chemistry, we have states of matter. We will study about atoms, molecules and compounds, what these are, right? Then we'll understand atomic structures. Then we talk about periodicity and chemical energetics, how energy behaviors affect these chemical properties or states of these of the matter. And then eventually we'll study the physical properties of metals, right? Now consider that some of these topics will be repeated in different blocks, right? So you don't need to worry that I'm having different chapters, the same chapter but has different portions, right? Now in analytical chemistry we will study stoichiometry. Now this is what we call as balancing of equations, if you remember, right? If you remember the writing chemical equations, how those chemical reactions work out, how we balance them, how the number of moles, how many number of atoms will be required. So all of this will be discussed in stoichiometry. Then we have chemical reactions in general, how some chemical reactions proceed, why some chemical reactions are endothermic, why are exothermic. Then some of them require activation energy, some of them having catalyst will reduce the activation energy. How these concepts work we'll discuss in chemical reactions. It will be spread over 3 chapters in the book, right? And then we have experimental techniques, which is the most critical topic in analytical chemistry, because this is the base of analytical chemistry. How these things are identified, right? How chemicals can be identified, how you can identify the properties of one chemical, how you can identify the composition of one chemical that is given to you. An unknown chemical I gave you in the lab, how would you identify what it is, right? So these techniques will help you identify what kind of unknown compound you're given and what kind of properties would it have. And finally, we'll discuss again the chapter of metals, but at this point we will only discuss the corrosion of metals, right? How the metals get corroded, how metals participate in reactions, right? Now in inorganic chemistry, as I said, it's mostly based on acid, base and salts. So we'll mostly be talking about oxides, hydroxides, carbonates and many other types of salts and their properties, right? How these inorganic compounds and what kind of properties they have, how they participate in reactions, what are the significance of these compounds. For example, one of the most common compound that I always suggest is magnesium oxide, right? It's milk of magnesia, also known as, it's a suspension of the salt given in water when you have stomach inflammation, right? Acidity. To control acidity you use hydroxide, right? Magnesium hydroxide. Then you also use carbonates in cooking, baking powder, right? Sodium bicarbonate, sodium carbonate, soda, right? We usually call those as caustic soda and baking soda, right? Sodium carbonate and sodium bicarbonate. So these are the basic inorganic compounds that we'll be discussing, and the properties of these basic inorganic terms, like acids, what are the properties of acids, then bases, how they react, what are the basic properties, and salts, and what type of salts are there, how salts are formed, and where these salts can be used and how can be prepared, right? Then hydrocarbon, again we will discuss mostly hydrocarbons in organic compound. Then we'll also discuss types of organic compounds, like we have alcohols, right? We have ketones, we have polymers, functional groups we have, right? So halides we'll discuss. So how these can be formed, what is the significance of those compounds, how to write the names of these hydrocarbons and organic compounds, nomenclature of organic chemistry, which is quite bit of a tricky thing to deal with, but once you get a hang of it, it's pretty easy to do, right? How to write the names. They're very odd names of these chemical compounds compared to inorganic compounds, right? And then in industrial chemistry we will be dealing with metal extraction. Again we'll be referring to the chapter of metals. And then we have sulfuric acid, which is the unit of industrial chemistry entirely, right? How sulfuric acid is made. And then we have ammonia production, and then we have gas production, right? Okay. In environmental chemistry, we will be only dealing with three topics. One is going to be air quality, then we will have water purification, and finally harmful compounds both in air and water that are produced. What are the sources of those harmful compounds? For example, carbon dioxide, burning, then nitrogen oxide, which is also coming out from the cars of the engine. It's not just the global warming that these car engines are producing, but also a toxin, and how these two, nitrogen oxide and carbon dioxide, are responsible for acid rains. Then we have sulfur dioxide released from different chemical factories like sulfuric acid production factories. They release some of the sulfur dioxide also gets leaked out, and how that can create harmful effects in the environment. So we'll be discussing a bit about it. This is one of the easiest topics in chemistry, right? Physical chemistry, environmental chemistry, and inorganic chemistry. These are easiest, and they also have easy questions coming in. Finally, electroplating, in which we'll study what the process of electrolysis is, what are the components of electrolysis. For example, the electrolyte, right? The electrodes, then we have the power, the ions, right? So all of that we'll discuss in electrolysis. Then we'll understand the application of electrolysis in terms of electroplating, right? How one metal can be deposited onto another, again compositional changes. Then we have galvanic cells. We also call those as batteries, right? The common name is batteries. The chemical name is called galvanic cells, right? All those batteries, chargeable or dischargeable. In other words, primary cells or secondary cells. Primary cells are non-rechargeable, and secondary cells are chargeable ones, right? The recharging batteries we have are called secondary cells. So those are galvanic cells, both of them. How they produce electricity using chemical reactions we'll study in detail, and then eventually we'll study fuel cells. For example, the hydrogen and oxygen fuel cells, right? The water cells we see. You do know about hydrogen fuel engines, right? Electrolysis based engines that are now coming into the market. They will be replacing the EVs, since we can't make that many batteries, and batteries are also unaffordable. So we'll be shifting to water based engines compared to those conventional engines, or the futuristic batteries, so called electric vehicles, right? Now this is, yes. Yes, you're very right that, yes, fuel cells are going to be the best. Yes, your fuel cells are going to be the best. Reason being, fuel cells, they do not have any carbon imprint, they don't have nitrogen imprint, and that is why this is clean engine or clean fuel, right? Hydrogen fuel is also now termed as the clean fuel. Reason being, once you burn hydrogen, it only requires oxygen, and once oxygen and hydrogen react, they burn, they give you the heat, but in general they release only hydrogen and oxide, which we call as water, right? So water is not harmful, it is actually essential for life. So it is actually not harmful. It is on the contrary supporting the rain structure, which is now going off due to the carbon release, right? Because of the global warming, we are losing rains, and these you can say is so called similar to steam engines, right? It is just like a steam engine, except it's not using carbon fuel to make steam, but it's making steam as a byproduct, right? Rather than the product that we require. So this is a very efficient as well as a more less harmful way of dealing with fuel systems, right? Now, this is the most important thing that I always discuss. Some of you, those of you who have attended any of my chemistry classes before, Ira and Barira, you haven't, but I think Abdullah would recognize this, right? So I discuss chemistry. Yeah, you just got the idea from where I'm starting, right? So this is where I start chemistry, right? This is the basics of chemistry in my opinion. So a substance can be divided into two ways, which I call as pure substance and an impure substance. Now, a pure substance, it can be further divided into two types: elements and compounds. And impure substances, which may or may have more than one type of substances together, are solutions and mixtures, right? Now, I'm going to define each of these. Yeah, no, I know the arrow is. I couldn't find the other arrow. Please don't mind the arrows. I couldn't find other arrows in the software, right? I'm using, yeah. Okay. Impure. Yes, impure. Yes. Yeah, they're not chemically fused together. Very well said. Very well said. So we'll define pure substance as a substance that has only one type of atoms, right, or molecules. And again, since we're dividing pure substance into elements and compounds, so we have one type of atoms if we are talking about elements. Examples could be metals, which are just one type of atoms. Then we have noble gases. Then we have other gases, elemental gases I call them, right, or elemental compounds, right, which are hydrogen, H2 gas, hydrogen gas, oxygen gas that we breathe. Now both of them are not an atom but in a molecular form, but since it is elemental in nature, it has only one type of atom, which means only oxygen, so it is still an element, right? Similar way, sulfur is found in S8 form. That means 8 sulfur atoms are joined together to form one large molecule of sulfur. And similar way, phosphorus occurs in the form of P5, right? 5 atoms of phosphorus are joined together there when they're found in nature, right? When they're extracted. So they are still elements, they are not compounds. Now when we talk about compounds, they have more than one type of atoms and they are all molecules compared to elements which may be elemental or atomic in nature, right? Noble gases are atomic, they are monatomic, they only have one atom, right? They don't need another atom to join, right? Because they're stable. We'll discuss later, right? So more than one type of atoms, they form molecules. Examples would be HCl, NH3, NaCl. Then we have ethanol, right? CH3COOH. So there are three elements joined together, 2 elements joined together. So different of these, when they join together, they form compounds, right? Now in contrast to these, when we talk about impure substances, they already have more than one of these pure substances. When you take 2 or more pure substances and you mix them together, they form impure substances, right? And they can be termed as solutions if they can mix together very well, and if they cannot mix together very well, we call those as mixtures, right? So we say homogenized properties all over for solution. That means if you take a dropper and you have a solution of ink, so if you mix it, stir it up, right, and you take a little bit amount of ink solution from the top, from the middle, and from the bottom, I think the solution is going to be same all over the place, right? But in contrast to this, right, for example, salty water, right, that's another example, a solid solution with water, right? Compared to this, when we talk about mixtures, they have their individual properties, right? They don't have mixed up properties. For example, sand and water. So if I may mix some dirt and water and stir it up and quickly takes 3 samples, I will still get less dust or less sand on the top, somewhat more intense dust in the middle, and bottom is going to be mostly sand and very little amount of water. So they don't have homogenized properties. Homogenized means mixed up, very well balanced properties, right? We'll discuss in the topic of diffusion how these are working out, right? Now this is the tree of chemistry. That means this is where you understand how compositional changes from one to the other go about, right? Any questions so far, girls? Are we clear with this? You have studied some of these topics already in advance. That's why I'm not focused much for now but I will be getting back to you with the questions, right? Okay, Abdullah is giving a big thumbs up.